determine the electrical service requirements for a 2,000 square foot commercial art showroom with two 240 volts 4-ton heat pumps totaling 16 kilowatts of auxiliary electric heat and a 120/240 volt service located 100 feet away, several calculations must be performed. Firstly, we need to calculate the lighting load. For a commercial building like an art showroom, we assume a lighting load of 1.5 watts per square foot. Therefore, the lighting load equals 1.5 watts per square foot multiplied by 2,000 square feet, which equals 3,000 watts. Secondly, we calculate the receptacle load. We'll assume the receptacle load is 50% of the lighting load. So, the receptacle load equals 0.5 multiplied by 3,000 watts, which equals 1,500 watts. Thirdly, we need to determine the total load. The total load is the sum of the lighting load, the receptacle load, and the heating load. So, the total load equals 3,000 watts plus 1,500 watts plus 16,000 watts, which equals 20,500 watts. Now, let's determine the service size. Based on the total load of 20,500 watts, the required service size is 100 amps at 120/240 volts. Next, we must determine the appropriate conductor size. Referring to Table 310.16 of the National Electrical Code, NEC, the minimum conductor size for a 100 amp service is number 2 AWG aluminum or number 4 AWG copper. To determine the number of home runs required, we start with lighting. Assuming 120 volt lighting circuits, each 20 amp circuit can handle 2400 volt amps. The number of lighting home runs equals the total lighting load divided by 2400 volt amps. Therefore, 3000 watts divided by 2400 volt amps is approximately 1.25, rounding up to 2 home runs. Now let's calculate the number of receptacle home runs. Assuming 120 volt receptacle circuits, each 20 amp circuit can handle 2400 volt amps. The number of receptacle home runs equals the total receptacle load divided by 2400 volt amps. Therefore, 1500 watts divided by 2400 volt amps is approximately 0.625, rounding up to 1 home run. Finally, since the main service panel is located 100 feet away, we must consider the feeder size. Using Table 310.16 of the NEC, the minimum conductor size for a 100 amp feeder over 100 feet is number 4 AWG aluminum or number 6 AWG copper. The NEC provides tables to determine the ampacity of conductors based on their size, insulation type, and installation conditions. These tables account for the conductor's ability to dissipate heat without exceeding its temperature rating. For example, Table 310.16 lists the allowable ampacities of insulated conductors rated up to 600 volts, not more than 3 conductors in a raceway or cable or earth, based on ambient temperature. When selecting a conductor size, you must ensure that its ampacity is sufficient to carry the calculated load. It is essential to consider voltage drop, especially over longer distances. Voltage drop occurs when the voltage at the load end of a conductor is lower than the voltage at the source end. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. To mitigate voltage drop, you may need to increase the conductor size. The NEC provides formulas and tables to calculate voltage drop based on conductor length, current, and conductor properties. In this scenario, with the main service panel located 100 feet away, voltage drop is a significant consideration. You would need to calculate the voltage drop for both the lighting and receptacle circuits to ensure they meet the NEC recommendations. Remember to consult with a qualified electrician to verify these calculations and ensure compliance with all applicable codes and regulations. Incorrect wiring can lead to safety hazards and equipment damage. Therefore, it is crucial to have the installation inspected and approved by a local electrical inspector. When installing conductors, it is important to follow proper wiring practices. This includes using appropriate connectors, ensuring proper grounding, and protecting conductors from physical damage. The NEC provides detailed requirements for wiring methods and materials. For example, the NEC specifies the types of raceways that can be used in different locations, the spacing requirements for conductors, and the methods for terminating conductors and equipment. Grounding is an essential aspect of electrical safety. A proper grounding system provides a low impedance path for fault current to return to the source, which helps to trip over current protection devices, such as circuit breakers, and prevent electrical shock hazards. The NEC specifies the requirements for grounding electrode systems, equipment grounding conductors, and bonding. It's also important to consider the load characteristics of the equipment being served. Some equipment, such as motors and transformers, have high inrush currents when they are first energized. Inrush current can cause voltage dips and potentially trip over current protection devices. To address inrush current, you may need to use larger conductors or install special overcurrent protection devices that are designed to handle high inrush currents. When calculating the total load, it is important to account for any future expansion or changes in the building's use. It is generally recommended to oversize the electrical service to accommodate future needs. This can save time and money in the long run by avoiding the need to upgrade the service later. In this case, consider whether the art showroom may require additional lighting or equipment in the future. If so, you may want to increase the service size accordingly. Also, remember to factor in the power factor of the loads. Power factor is a measure of how effectively electrical power is being used. A low power factor can increase the current drawn from the electrical system, which can lead to higher energy bills and voltage drop. If the art showroom has a significant amount of inductive loads, such as fluorescent lighting ballasts or motors, you may need to install power factor correction capacitors to improve the power factor. These capacitors will reduce the amount of reactive power drawn from the system, which will lower the current and improve the voltage. When selecting overcurrent protection devices, such as circuit breakers and fuses, it is important to choose the correct type and size for the application. Overcurrent protection devices are designed to protect the electrical system from overloads and short circuits. The NEC specifies the requirements for overcurrent protection devices, including their interrupting rating and time current characteristics. The interrupting rating of an overcurrent protection device is the maximum amount of fault current that it can safely interrupt. The time current characteristic of an overcurrent protection device is the relationship between the amount of current flowing through the device and the time it takes for the device to trip. The NEC requires that overcurrent protection devices be readily accessible and located in a safe place. They should also be clearly labeled to indicate their function and rating. It is important to periodically inspect overcurrent protection devices to ensure that they are in good working order. Damaged or defective overcurrent protection devices should be replaced immediately. Surge protection is another important aspect of electrical safety. Surges are transient overvoltage events that can damage or destroy electrical equipment. Surges can be caused by lightning strikes, switching of electrical loads, or problems with the power grid. Surge protection devices, SPDs, are designed to protect electrical equipment from surges by diverting the surge current to ground. The NEC requires surge protection in certain applications, such as dwelling units and critical facilities. It is also recommended to install surge protection in commercial buildings to protect sensitive electronic equipment. SPDs should be installed at the service entrance and at branch circuits that serve sensitive equipment. It is important to choose SPD that are properly rated for the application. The rating of an SPD is based on its surge current capacity and its voltage protection level. Emergency lighting is required in many commercial buildings to provide illumination during power outages. Emergency lighting allows occupants to safely evacuate the building in the event of a fire or other emergency. The NEC and other building codes specify the requirements for emergency lighting, including the amount of illumination required, the location of emergency lights, and the type of power source that must be used. Emergency lighting systems typically use battery backup or generator power to provide illumination during power outages. The batteries or generators must be periodically tested to ensure that they are in good working order. Wiring for emergency lighting systems must be separate from the normal lighting system to prevent the emergency lights from being affected by a fault in the normal lighting system. When installing electrical equipment in a commercial building, it is important to consider accessibility for maintenance and repair. Equipment should be located in areas where it can be easily accessed by qualified personnel. Clearances should be maintained around equipment to allow for safe working conditions. The NEC specifies the minimum clearances that must be maintained around electrical equipment. Equipment should also be protected from physical damage and environmental conditions. For example, equipment that is installed outdoors should be weatherproof. Equipment that is installed in a hazardous location should be explosion-proof. Electrical safety is paramount in any commercial building. It is important to follow all applicable codes and regulations to ensure that the electrical system is safe and reliable. Regular inspections and maintenance should be performed to identify and correct any potential hazards. Employees should be trained on electrical safety procedures and should be aware of the potential hazards associated with working with electricity. By following these guidelines, you can help to create a safe and productive work environment. For the electrical service in question, all calculations are for example only and must be verified by a qualified electrician.